Hi there, and welcome to a brand new webinar. This is the eighth time in this year when we would be discussing about platform engineering. And like always, I will be joined by some wonderful guests today. So today, our discussion point would be around agnostic app images using Buildpacks. And we will discuss, obviously, from the point of view of a platform as well. While some of you might be familiar with me, but for the others who don't know, I'm Atul Priya Sharma, and I am a senior developer advocate at InfraCloud. As part of my role here, I help individuals and enterprise get used to or adopt open source tools and technologies by means of creating content, things like developer documentation, blog posts, videos, and webinars like these. I'm also a CNCF ambassador, and I'm organizing my city's first KCD that is happening next month, which is KCD Hyderabad. So I do a lot of community work as well. And when I'm not doing any of these, either as a developer advocate or a CNCF ambassador, I'm a big time foodie and a travel blogger. So, you can find me at a restaurant trying out something new or traveling to a new place. Now, well, that's enough about me. I think I can go on and on about this. Uh, so, if you are joining in for the first time, or if you have missed watching any of our previous webinars, you can scan this QR code, which will take you to our YouTube playlist where you can watch all our previous webinars as well. And when you're on YouTube, why don't you go ahead and subscribe to our channel as well? Now, with that out of the way, as always, like I said, I'm joined with some amazing guests this time. So why not let me introduce you to my guests for the day. Let me bring upon Joe and Terence, who are joining me for this webinar. Hi Joe, hi Terence, thank you so much for joining in.
Hello, glad to be here.
Yeah, thanks for having us.
Great. So we have a tradition here. I don't usually introduce my guests, but I let my guests introduce themselves. So why don't Joe and Terence, both of you, introduce yourselves to our audience? In terms of what do you do, how are you associated with Buildpacks, and what are your interests outside of work?
Sure, I'll start. I'm a principal architect at Salesforce. I've been at Salesforce for about 10 years and currently working on our internal platform, which we call Hyperforce. So this is an internal platform that our developers use to build our products on. Prior to that, I had worked at Heroku, which is a subsidiary of Salesforce, for many years. And I worked there with Terrence. Outside of work, I think Terrence and I both like to play board games. So that's one of the common connections that we have. But I'll let Terrence tell a little bit more about Heroku.
Yeah, thanks, Joe. I've been at Heroku just past 14 years. So it's actually been a really long time. I helped found like Buildpacks technology back 12, 13 years ago, I guess, which eventually became the precursor to what turned into cloud native Buildpacks. And so we base a lot of our technology and learnings to kind of build that. And so it's only about 5 or 6 years old, but it's built on top of kind of battle tested lessons from Heroku and other companies that have used Buildpacks since then. And yeah, so I'm an architect at Heroku, and I've focused historically mainly on kind of languages where Joe and I work together, as well as kind of the built infrastructure over there. And then, like Joe said, outside of work, I do board game stuff, as well as I think we also both do running.
That's quite interesting. Board games and running. I think that's a great combination to have. And I'm sure everyone who is joining in are familiar with Heroku, irrespective of what role they are in. Because I remember when I started, I did build some applications demos using Heroku. So I'm sure a lot of the audience who are joining in would be aware of that or would have been impacted by it in some or the other way. Now, before we move on further into the discussion, some housekeeping stuff. We would be taking in questions. So if you have any questions, please feel free to put them in the comments box below, irrespective of where you are joining in from. And I would take that questions with my guest today, and we would try to answer that. So with that out of the way, I think we can proceed with the discussion today. And like always, we would be talking about platform engineering. Now, if you have been following the webinars, you know that every time I do a webinar on platform engineering, I come up with a new definition or a new analogy of platform engineering. And being a foodie, I have a foodie angle to platform engineering today. So I do eat out a lot, and there are a lot of restaurants that I visit for particular things. So, for example, if I want to eat a tiramisu, I know that I'm going to go at this particular cafe to have it. Or if I want to have a biryani, I will go to a particular restaurant and have it. And I'm sure that a lot of you who are viewing this would also have their favorite places to eat specific dishes. But have you ever wondered why is that so? So usually that's because of the quality and the taste and the consistency. So every time you visit a restaurant, you have the consistent quality, you have the consistent taste, and that is why you keep on going there again and again. Now, to enable this, there are a lot of things that happen in the background. So, for instance, the type of ingredients and the quality of ingredients, that's very critical. The processes that they use is again very critical. They need to have a standardized process in place to get these things out in a consistent manner with a consistent taste, and also the recipe that is behind it. So until unless the recipe is consistent, you will not get a consistent taste every time you visit. Now, this exactly is what a platform does. Now, putting it to a software engineering perspective, platform engineering involves creation of infrastructure, creation of tools and processes that allow developers to ship their applications, build them, test them, and deploy them in a consistent and repeatable way always. So, what a kitchen is to your restaurant, platform engineering is to developing applications. So that was my fun analogy to platform engineering today. And I would like Joe and Terence to share their versions of what they think platform engineering is. Joe, what do you think about it?
Yeah, I think your analogy is really apt. To me, what characterizes platform engineering is the ability to provide leverage to the users of that platform. And by leverage, I mean having a team that does something once, so that every other team doesn't have to repeat it again and again. And we'll probably talk, today about the different ways you can accomplish that. But that ability to provide leverage is what allows teams and the products they deliver to scale.
Interesting. Terence, do you want to add something to it?
Yeah, I mean, I think you're both pretty spot on. I mean, Roku as a company is a platform as a service. So, the entire company is basically trying to be platform engineering for a lot of other companies who may or may not want to invest as much kind of into that space. But yeah, I mean, it's about creating leverage. It's about trying to, do a bunch of things. So like the people who are consuming this platform can focus on delivering that business value instead of having to deal with all this other stuff just to like get their code um, and solutions out to their own customers, right? So it's about kind of creating all those tooling and processes in place to create that kind of efficiency, and
Mhm.
also so those folks just don't have to think about as much around like trust and compliance and those things, and those can be kind of handled um, outside of that.
Absolutely. I think standardization, consistency are the keywords here that the platform provides. Now, moving on, we while all of us have a brief idea about platforms, but when it comes to actually implementing a platform, we have realized that a lot of teams face hurdles in terms of how do they start about building a platform, or if they have something in place, how does that mature over time. And that is where we at InfraCloud came up with the platform engineering reference architecture ebook. And this ebook was released at KubeCon in Chicago. And the whole idea about this ebook was to help teams and organizations start their platform engineering journey. So, based on our discussions with our customers, our prospects, as well as the platform engineering community, we collected all our learnings and put it in this book. So, In this book, you will find blueprints and guides to help you get started. There are a lot of capabilities that a platform should have, which I will discuss in a moment. And we also have suggested a list of tools for each capability that you can choose to build your platform. This ebook is free to download, so all you have to do is scan that little QR code on your screen and get this book for yourself to start your platform journey. Now, as I said, the book has a lot of learnings, and what I'm going to touch upon today is the platform engineering capability map. Now, whenever you talk about platforms, you talk about platform engineering, the you cannot have I mean you cannot not discuss about capabilities, because capabilities are essential to a platform. So essentially all the services that your platform gives to your developers is considered as a capability. And in this ebook, what we have done is we have categorized these capabilities into three different areas. We have develop, we have consume, and we have discover. So the capabilities that help your developers build a new service, build a new application will fall under develop category. The capabilities that are basically services that they consume to build the application fall under the consume category, and the external services that are used, like monitoring your application, fall under the discover category. So on your screen, what you see is the capabilities under the develop category, which we are going to focus on today. So things like service templates, workload specifications, ephemeral environment, pipelines, inner development loops. Now these are the capabilities that your platform should offer, along with a set of tools for your developers to complete their journey. And our focus for today is inner development loop. So as developers, one of the common things that we do is basically getting into this inner development loop while we are building our application. So so we write code. Once we write the code, we build the application, we test the application, and then deploy it to, let's say, a staging environment or an integration environment or a development environment. And this process keeps on continuing always. So it's a rapid feedback phase, if I can say so. So you make changes, you deploy it, you test it, and then based on the output, you do it again. So you essentially keep on doing this as a developer multiple times in a day or in a week. Now, it has its own complexities associated with it, right? So one of the challenges over here is that the build time can be varied. So every time you make a change to your build, the build time might be different. And what happens in that case is that if the build time is longer, your entire loop takes a longer time. Secondly, if you're building applications that are to be deployed on different environments, then you have to take care of the dependencies for each environment. You have to consider the various, compatibility issues or configuration settings that comes with different environments. And that is again where developers spend a lot of time figuring out, how to get their applications deployed, and spend lesser time on building the actual application. And that is where today we are going to focus on how platforms can help you overcome this issue. And moreover, tools like Buildpacks, which are in the inner development loop and in fact do much more than that, which we will look in the next section of the webinar as well. Now, moving on to the first discussion point for the webinar today is the diverse deployment processes. So as a developer advocate, I create a lot of POCs day in and day out. And my POCs are built using different languages. They are deployed on different environments. So I deal with a lot of Docker files, a lot of configuration settings day in and day out. And there have been times where I had spent a lot of hours just figuring out why a particular application was working on a GKE but not on an EKS, because maybe some configuration went wrong. So my question to you, Joe and Terence, here is that you know that there are different ways of deploying an application when it comes to either the application type or the different environment. How do you think the absence of a unified approach actually impacts the deployment process?
Yeah, I mean, I think the lack of this is really what is the root cause of so many problems in our development processes, whether it's trust and security, because people are doing things in different ways and it results in snowflakes that have particular vulnerability that you're not expecting, or if it's just about availability and reliability, because a more heterogeneous fleet of services is more difficult to debug and understand. So yeah, I think as it comes back to platforms, that centralizing that ability to standardize and have consistency is what again allows you to scale and scale safely and scale in a way that is operationally maintainable. And I mean, if you look at what a platform the size of Heroku does, you can see that really functioning at a high level. And I'm sure Terrence can speak to that.
Yeah, thanks for the segue, Joe. Yeah, I mean, at Heroku, for the most part, for its long tenure, we had classic Buildpacks, and then at the end of the day, like they would go build a thing and they'd create this runnable artifact that we called a slug, and that would be separate from the rest of the application base image. And the fact that like it's like done the same way, no matter if you're bringing a Python app, a Ruby app, or a Java app, meant that on the platform side, we could standardize a lot of things, kind of taking advantage of all the kind of scale and other things Joe talks about. So we're able to do things like, because we've separated out the application layer and the underlying base image, and we also force people to use, a limited number of, I guess, base images. So like as an end user, I can't just pick what is my underlying operating system. You pick from a set that Heroku says you can use. That allows us to guarantee that that base image has ABI compatibility guarantees, and then that we can safely kind of update that without having to rebuild your app each time, right? Because that doesn't work at scale as a platform. Like we have that also allows us to like allow all this untrusted stuff where we don't know what someone's doing during a build, and nor do we really care, right? So I think it allows us to make some assumptions there by having that standardization.
Interesting. I think you actually really mentioned the great part here where you try to separate the app layer with the actual base layer, and that is where the entire flexibility comes into the picture. And we already discussed that configuration is a challenge when it comes to deploying applications on being developed in a different language and then putting it to a different target. And I think this separation actually helps with that. So now moving on, I think while we discussed the actual challenges where it comes in, whether it was based on my experience or the inputs that you gave, how do you think a platform would actually come up and help to streamline this entire build and deployment process? While you did give us an insight into how Heroku does, I would like you to probably dig a little deeper and share insights on how a platform actually helps us achieve or overcome the challenges that we have discussed.
Yeah, I mean, I think you said the magic word is layers, right? And I think that's the way, and so many things in computer science come back to this, whether it's how we deal with the operating system or networking or the physical infrastructure that is underneath our networking. It's all about layers that provide, abstraction, for lack of a better word, but more fundamentally, a way for developers to focus on the thing that's important to them. And for most people building applications and products, it is that product. It is creating something that is valuable to their customers. And every second that they spend on debugging the operating system or networking issues is toil and is not adding value to their business. And so, efficiency at any layer that you're at is making sure that the platform you're working on is structured in a way and provides the right abstractions to let you focus on what's most important to you.
Yeah, I think Joe really hits the nail on the head here of, just being able to abstract away what you have to worry about as a user and kind of consumer of this platform, right? Like at the end of the day, like platform engineers are there to kind of create these efficiencies and develop those things. So we talked a lot about standardization, especially with the food analogy. But I think those things allow, like, if those deployment pipelines, like, I don't have to worry how to get my code to production, right? Like, I don't have to worry about whether my image is signed, right? Even though that's a requirement for me deploying, like, inside of this business, because that's important. Like, if we can take those kind of things away, it creates this efficiency where you can focus a lot more on just the things you need to worry about. And the benefits of platform engineering for all these companies is that as a platform engineering team, you get to kind of just work with the business to decide, like, what is actually important for the business, and to build in that platform. Because every platform shares a lot of these kind of similarities of, like, at a high level trying to do these things, but it's going to differ from business to business of, like, where that value is and where those where kind of those kind of touch points meet between the platform engineering team and the application developer of what they have to focus on.
Interesting. So, I would like to touch upon one of the points that we discussed in our earlier webinars, where Terence, you mentioned, that the definition of a platform might change for a different organization. And that is where, we touched upon the concept of the context of platform changing, not only amongst different organizations, but also in the maturity journey of the platform itself. So, when you actually start building a platform, it has a different context. But as and when your developers start using it and your platform start growing, the context keeps changing, and that is how the platform also keeps evolving. So that's a very valid point you have mentioned. Joe, since you spoke about abstraction, I think that's the word that you mentioned, and I think whenever we talk about platform and platform engineering, there is always a debate between abstraction versus flexibility. How much you abstract and what is the flexibility that you
Yeah.
give. So just an open question, your
No,
thoughts on
really,
this.
really important question. And I think it has led to a lot of pushback on abstractions, right? Especially because when you get the wrong abstraction or do your abstraction wrong, you can create friction. You can slow your developers down. Getting the right abstraction is hard. And I think for that reason, you see a lot of discussion, especially like in the developer experience space, moving away from abstractions towards what's often called revealing complexity. And that does come back to layers, but it's more thinking about how developers work their way down through these layers. So you start at a higher layer, you focus on those things, but eventually you need to, you know, drill down a little bit deeper, make some customizations to your Helm chart, customize the Kubernetes cluster. And at each layer, you're getting more power, and with that comes some more responsibility and risk. I think though that there is, I think these two can be married, right? Like I think abstractions are still valuable, and one of the ways in which we can ensure that you have an abstraction that works for you, and actually to be more clear, works for everybody, which is even harder, is to provide extension points in that abstraction. And that's really what Buildpacks are, and we'll talk about it in a little bit. But there are so many different things about a platform, or so many different ways in which a platform can and should have extension points, because that's what allows a developer or user of that platform to enhance the platform, to add new capabilities to it, to work around those spots where the abstraction didn't work for them. I think there's many examples of this. If you're working with a CLI, CLIs very often have plugins. That's the most straightforward, example of an extension point. And as I said, Buildpacks are one of those too.
Yeah, I think Buildpacks are a great example, but I would say it's really hard to get the right abstraction out the gate too. Oftentimes I think it will be the right abstraction at the time, and then like you mentioned, like the context changing, like your platform evolves, right? Like as your business use cases get more complex, as you onboard more users, and there's like things you didn't account for, right? And like even at Heroku, like Buildpacks were a thing we invented after the business launched and after we became a PaaS. And I think oftentimes it is helpful to sometimes not even start with the abstraction. Like we were a Ruby only platform to start, and then we eventually got to the Buildpack thing when we wanted to become a polyglot platform. And I think one of the nice things with some of those extension points too is like build the solution that makes sense at the time, and then figure out, okay, now that I have more information, like how do I abstract that? How do I, instead of like trying to solve everything from the get-go sometimes, because that can just take too much time, and you also just don't have the information, right? And so, I think one of the things we were able to hit with Buildpacks really well, swiftly on Heroku, was the ability to kind of take that information in from our learnings, figure out how to then build the right abstraction and extension points that made sense, and then continue to provide that curated experience that we had with that specific solution, but on top of like this new set of primitives that allowed people to break the class when they needed it.
Interesting. I think, both of you mentioned two key lines or two key terms that are very critical. Joe mentioning that wrong abstraction will create a lot of friction. And that's, I think, hitting the bull's eye that, if you are, and also, correlates to what Terence, you mentioned that, you don't start with abstraction at all when you are beginning with, and, only as and when your platform probably grows, you decide how much of things that you want to extract away from your developers. So, that's my learning for today. Wrong abstraction leads to friction. So the audience, if you have anything in particular that you have you have in mind that you want to ask our guests, or if you had something learned new from this discussion, like I picked up, wrong abstraction leads to friction, do let me know in the comments as we go on for the next part of the discussion. So now, let us get into the meat of today's webinar, where we would be discussing Buildpacks. So, before I hand it over to Joe and Terence, Buildpacks is one of the tools that we have listed in our ebook under the inner development loop capability. But as I said earlier, it does much more. So, I will hand it over to Terence, who will let us know more about what Buildpacks is, and from a platform engineering concept, how it is going to help our developers improve. So, Terence, the stage is all yours.
Thanks, Atul. Yeah, so for people who aren't familiar with Buildpacks at all, you're just coming to this webinar to learn about it. We're a CNCF incubation project, and quite simply, like what Buildpacks, they take source code, they transform it into an OCI image, at the other end, without the need of having a Docker file as part of that process, right? And so you get an OCI image that maps logically to your application. The Buildpacks themselves are these modular units that encapsulate, all the concerns of a specific technology. So you can have a Buildpack, for Java. You might have another one for Maven, Node, Python, etc. Right? And this allows, as an application developer, so we have these kind of different target personas. So as an application developer, if you're using Buildpacks, you can focus on how to build your application without worrying about how do I artisanally copy paste things into my Docker file to get what I need into it. The Buildpack's taking care of that, right? And as a Buildpack author, you're building these shareable units that can be used across your company. And so, we talked about standardization earlier on the talk about deployment standardization. So Buildpack authors allow you to kind of create that leverage to do things like Java should be built the same way across my entire company, right? There should be one way we build Java apps. And that doesn't mean all of them have to be shaped the same way, but you're basically creating this leverage point of this one place is deciding how Java is going to be built, across the entire company. And then you have platform operators on the other end where, Buildpacks are actually these composable units. So this allows you to kind of bring a Java and a Node Buildpack together and make them work together. Because maybe I'm using Spring Boot application, so I need my Java app, my Java Buildpack, and then there's assets that are part of that for the front end that I have to compile my Vue or React app that's part of this single OCI image, right? And so this kind of power allows platform operators to get away with supporting significantly less base images. So oftentimes you see in a company I have to have my Java base image for Rel 9 or my Node or Python base image. And so since the Buildpacks are handling all these application concerns on top of it, I can actually just support this Rel 9 base image and then have Buildpacks kind of build that stuff on top. So you can really reduce the number of base images you have to support as a platform. And so all these things allow you to kind of create these organizational efficiencies that we've been talking about through this webinar, where these different personas can focus on kind of the areas that is best suited for where they are delivering value to the business. And so one, like we touched on, I was talking about like, oh, like it's really nice that Heroku allows you to, like, we have the slug, we can separate the application layers from, the underlying base image, which allows Heroku to do, these nice like base image updates. So with Buildpacks, we also have carried this concept forward. So, one of the most expensive things I think to do with a Dockerfile built images is that when you have to do a base image update, it actually invalidates that first line, which is the from line, which busts every single cache layer below it. So you have to literally rebuild our applications when you're, dealing with a type of CV like the log4j, like log4shell thing, right? It's like you probably have thousands, millions of images that you have to update depending on your company. And you got to like actually build every single one of them. This can take a significantly a lot of compute time and can be a long time to kind of roll that stuff out, right? And so with Buildpacks, because we actually know where the application starts and the base image ends, we keep track of that. We can actually do a simple text manipulation because, OCI image manifests are just JSON files, right? And they keep track of all the layers. So we can actually do this lift and shift where, assuming you're using an ABI, guarantees in your base image, we can actually just take your existing app layers, move them on to the new operating system layers and get an entirely new OCI image without doing a rebuild, because you're just manipulating the JSON text here, right? And the other nice thing is when you're actually rolling this out to a fleet, assuming you're like using the same node underneath, like you already have those application layers. So all you actually have to do is roll out these operating system layers like to your entire fleet to kind of get like this kind of CV patch. So you're getting this like really nice efficiency there. And I'll actually hand this off to Joe here to kind of kick off how you can like quickly get started with Buildpacks and see it running in action.
Yeah, thanks, Terrence. So I'm going to do a little demo of using the Pack CLI, which Terrence talked about, to turn a simple Java application into a container image without using a Docker file. So what I have here is, again, a basic Java application using Maven. I really just went to start.spring.io and generated a new app and then added a little bit of my own code into this demo application class. So it has a hello route that we'll test, and it just responds with hello world. So here you can see that hello path and the function returning hello world. So pretty standard Java application just for demonstration purposes. The first thing I'm going to do is run the pack build command. And I'm going to provide it with the Heroku builder image. So the Heroku builder image, or any builder image, is a way of encapsulating the environment that a build pack runs in. So what this is saying is this is the base image and all the build packs that I want to use to build my app. There are many other builders. There's a builder from Google. There's a builder from the Paketo project, which is maintained by Broadcom VMware, and some others. And you can also create your own too. So it's an open model. But when I run this command, the first thing it'll do is run detection against my app. And you'll see here that it discovers I need to install a JVM and that I'm using Maven. So these are the two build packs it's going to use. So the first thing it does is install the JDK, and then it installs Maven, sets up the environment to run Maven, and then runs Maven for the first time. And of course, first time it runs Maven, it has to download all of my dependencies. But while it's doing this, it's putting these dependencies into a well-structured cache so that the next time I run this command, it can leverage that cache and also demonstrate how in some unusual circumstances, it can preserve that cache in ways that like a Docker file cannot. So after just a few seconds, it will finally export an image, and it also sets up this image so that it's ready to run. So because I'm using Spring Boot and Java, and these are known things, it knows exactly how to start my app. I don't have to tell it how to do that. But it is just a regular container image, so I can use Docker inspect or other Docker commands against it. So here I'll run Docker run, and I'll publish the 8080 port, and my image name is my app. And you'll see that it starts up with some default options. So the build pack is actually configured the image to run efficiently based on intelligently on things it discovered. You can see Spring starting up there. And then if I just run a simple curl command at that hello path, I should get my hello world back. So just like that, without having to author a Docker file or instruct it on how to run my app or how to configure the environment variables and things like that, the build pack just got me up and running really quickly. So it's a great way to, speed up your inner loop and let you, again, as we said before, focus on the things that are important to you, which is actually the business logic in that service and not all the infrastructure that builds the container. But because of the way build packs are designed, they work inside of a platform as well. So when you push to Git or run a CI job in your platform, you can leverage build packs there and get the exact same result. As I mentioned, this image it maps logically to my application, both in the actual image itself and the cache that it has. And so that allows us to do some more advanced caching techniques. And one example is if I need to change the Java version. So there I've just opened my system properties and I've upgraded from Java 17 to Java 21. If I was using a Docker file or some other mechanism, that would immediately bust all of my cache layers. In fact, just editing the system properties file might bust my cache layers. But because of the way build packs structure the cache, and because the build packs are aware of the context of Maven and Java, they know that they can preserve this cache and reuse it. So here you see it's restoring metadata and cache from all of my previous layers. It's reinstalling the JDK because that's the one thing it has to do. I've got a new JDK version, so it won't be using that from the cache. But then after that's done, it uses the same Maven that was installed before, and it uses the same Maven cache. So those cache layers are not busted. And my Maven build happens very quickly, and I get a new image, and then I can run that image again and confirm that it's working with Java 21. So when Spring starts up, it'll say that. So there's just a good example of how the advanced caching techniques improve both your developer inner loop, because you can build your container image more rapidly despite significant changes like this, but also how you can scale more efficiently as you're building in CI and on your outer loop process into going into production. And the advantages, as Terrence mentioned, they really get even more powerful the further down the stack you go. So as you're updating things like the operating system, you don't even need to run this pack build command, because we can leverage that ABI compatibility, that binary interface compatibility to take advantage of that. So we don't even have to recompile our code or build our image. Cool. So that's the demo. I'm not sure if I'm turning it back to Terrence or Atul, but yeah.
Yeah. You can find us. I guess Joe was mentioning some other platforms to kind of close this out. He was showing off Pack, which you can run locally. Docker daemon. There's a Tecton CI/CD thing. As part of the project, we also have Kpack, which is Kubernetes operator that you can use to kind of use build packs in your cluster. And then actually even part of the Spring Boot project, they have build packs integrated to build production grade images right out of the gate. And you can find us on the CNCF Slack under the build packs room. We're on GitHub at /buildpacks, and would love to, welcome questions and anyone who's part of this webinar to come engage with us as you're getting started on your journey.
Great stuff. Thanks so much, Terrence and Joe, for that wonderful introduction. And rather, I would say, it was a good deep dive into what Buildpacks is. I'm sure it's a C. There are a lot of concepts involved, but I think the demo did give a good taste of what Buildpacks can do. And I personally found it very relatable because, off late, like I said earlier, I've been my work involves doing and building a lot of POCs. And recently I've been dabbling with Java, and I could easily relate to when you mentioned, updating the Java image and then everything going haywire, and, the dependencies, the versions, and then that actually leading to me spending a lot more time to figuring out what the issue was. So I think the demo that you gave that spoke about the caching capabilities, where it understands what the underlying layers are, and then that actually helping us to quickly build the image, and thus making our inner development loop much more faster and efficient. So yeah, thank you so much for the demo once again. So everyone who are here, you can check out Buildpacks. You can join their Slack channel, slack.cncf.io. You will find the Buildpacks channel. You will find Joe, Terence, and the larger Buildpacks team there, where you can go ahead and learn more about it. If you have any queries from the webinar that they have done today, if you are not able to put it in the comments or have it here, most welcome to go and discuss in the Slack channel. They are also quite active on Twitter, and since it's a CNCF project, it's available on GitHub as well. So go ahead, clone the repo, understand what Buildpack is, and see how it helps to make your process easier. Okay, there is one question coming from Peter, and he says it's a noob question. So I'm just putting it on screen. Is there a difference between Buildpacks and cloud native Buildpacks? Joe, Terence, any of you would want to take it up?
Yeah, good question. I'm going to let Terence take that one.
You'll let me take that one? So Cloud Native Buildpacks specifically are the CNCF project. And I think Buildpacks is, can potentially, depending on the context, refer to that, or kind of the older, I think, like Heroku, I guess we call them like V2 Buildpacks. But it can sometimes refer to kind of the older Buildpack technology there. And so that's probably like the big difference between them, is that the Cloud Native Buildpacks one is the OCI image-based one that we've been talking about and demoed.
But today we pretty much use them interchangeably. I think, yeah. So I think the short answer is no, but if you account for all of history, yes.
Yeah.
Great. So I guess, Peter, you got the answer. Joe mentioned interchangeably, yes, you could use it, but then the history, when you go back in time, you would realize how both the cloud native Buildpacks and Buildpacks have the slight difference between them. Thanks so much, Peter, for that question. And I will add it from stage. Anyone else, if you have any further questions, please feel free to ask. We have our guest still here. So meanwhile, I would just like to sum up the discussion today. I'm sure a lot of you who are building applications day in and day out would relate to the issues that we discussed today. Talking about how the application building, deploying processes, and how it varies from different environment to environment, leading you to spend more time troubleshooting the issues rather than focusing on core aspects. And that's where we discussed how platforms can help standardize that entire process. Terence mentioned about, let's say, if you are using Java for your team, a platform can particularly, have some guardrails in place, ensuring that the entire team uses the same Java version as well. And lastly, we had a cool demo around Buildpacks. We saw some of the advanced capabilities that Buildpacks has, right from caching capabilities, which actually handles a lot of version and dependency related issues, and then the whole architecture of Buildpacks, the layers that are in place, makes it much more lightweight and easy to use. Now, as I was summing up, I did find a question coming in from Vikas, which I'm going to put up on the screen. So Vikas is asking, is there any interesting upcoming feature for Buildpacks in the roadmap? That's quite interesting. So what's something exciting that's coming up that you can share with our audience today?
Yeah, I can at least start. One of the things that we've been working on over the last year or so has just been, you can do multi-arch stuff with Buildpacks today, but it hasn't been the easiest experience. Like Joe was showing the builder, right? Like, so in order to like actually build a multi-arch image, you kind of need not only your Buildpacks to be multi-arch, but then also the builder itself to then get a end user image that is also multi-arch, and so one things that we've been investing in heavily has just been just continuing to make that as a better experience for Buildpack authors to provide those multi-arch images. So we've been doing a bunch of work in Pack, and Juan, who's the kind of lead on the Pack project, has been putting in a bunch of time over the last year plus, I think, to kind of make that a simply better experience for Buildpack authors.
Great.
Yes.
I think, yeah, go ahead, Joe.
Yeah, I would say one of the things that's not necessarily on the roadmap, but something that we shipped more recently is called Buildpack extensions. And those allow you to actually combine Dockerfile with Buildpack so that developers can provide sort of a snippet of Dockerfile if there's something that they need to customize at a lower layer. Kind of comes back to that revealing complexity that we talked about earlier.
Interesting. So two interesting things are happening, multi-arch images and extensions. Personally, multi-arch images are something that I've dealt with in the past for one of the projects that I was working on. And it's quite difficult to get that working, like Terence mentioned. And I think that would be a good feature, a good handy feature to have in the future. So with that, we come to the end of this insightful and interesting webinar. I would like to thank Joe and Terence for their time. Thanks for joining in and sharing your insights into Buildpacks and giving that wonderful demo to our audience.
Yeah, thank you for having us.
Yeah, thanks for putting all this together.
Great. So once again, thank you everyone for joining in. Again, if you have watched this webinar and in case you missed out on something, head to our YouTube channel where you can watch this webinar again. And you can download the Platform Engineering Reference Architecture ebook by scanning the QR code. And anything you have related to Buildpacks in the future, please feel free to connect to Joe and Terence in the Slack channel or connect with them on Twitter or GitHub. So once again, thank you so much for your time. Stay tuned to our social media channels on Twitter and LinkedIn for the upcoming webinar as well. So thank you and have a wonderful day.